Mr. Herdum here. Today, we will go over reaction stoichiometry using molarity. Molarity is the big M. In AP chemistry, they will just use the word concentration for this word. You are supposed to know that it's molarity, which is in moles per liter. Okay, Mr. Herdum, get rid of that voice and use your normal voice here. So we will be using the conversion factors, moles, number of moles equal to 1 liter. So in example 1028 here, we have 25 milliliters of nitric acid with a concentration of 0.2688. Molarity is neutralized by 31.45 milliliters of strontium hydroxide, this is supposed to say. What is the concentration molarity of the strontium hydroxide base? So this is moles per liter that we are looking for. So the first thing we need here is a reaction here. This is an acid-base reaction. An acid-base neutralization reaction. If I could spell neutralization, that would be great. Remember that this is a special type of double replacement reaction where we take nitric acid. This is the acid of nitrate. Nitric acid is the strongest acid that you can have. That is just one acid. So we have HNO3, because nitrate's -1 and hydrogen's +1. This is aqueous. Plus strontium hydroxide, SrOH2, +2 and -1. Remember, you always have to write the compounds correctly, right? And we do remember hydroxide, right, is OH-. Look, I found hydroxide paper. I need to put some minuses up here so that it's hydroxide, but I found hydroxide paper. Awesome, huh? Anyways, so in an acid-base neutralization, strontium hydroxide is a strong base. We are going to make water as our neutral compound, as HOH. That is a liquid, +1 and -1. And then we are going to have strontium nitrate as our salt, +2 and -1. So there's a 2 right here, and you balance the reaction by putting a 2 here and the 2 there, correct? Okay, let's make a map and try to figure out what we're doing here. What is the concentration molarity of strontium hydroxide base? So we are looking for the moles per liter of strontium hydroxide. Okay? They gave us 25 milliliters of nitric acid. I am going to convert that to liters using the metric tape. And then I am going to convert that to moles using the molarity. Then I am going to do my wham, 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 which is the reaction, because everybody loves me saying wham, 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 wham. Right. Then I'm going to go to moles. And then I am going to go to liters by dividing by the liters of solution. So in this problem here, I am going to start off with 25 milliliters of nitric acid. And let's do this in black. Okay. I am going to go from milliliters to liters, liters to moles, because that's the molarity step, and then I'm going to go to moles using the reaction, right? And we know that this is HNO3 here, HNO3 here, HNO3 here, HNO3 here, HNO3 here, and HNO3 here. And then this flips the strontium hydroxide over here. Okay? Now that's not my whole T-chart, but it's a start. So I know that there is 1 times 10 to the third milliliters in 1 liter. Swish, swish. And then, so I've used my 25 milliliters of nitric acid with a concentration of 0.2688 molarity. Remember, this is moles per liter. So that is really saying that there is 0.2688 moles in 1 liter. Okay? Do I need to write that down somewhere just to help you out here? 2.688 moles in 1 liter. Then we do my famous wham 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 whams. Wham 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 wham. 1 mole of strontium hydroxide. Wham 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 wham. 2 moles of HNO3. So our goal is to get to moles per liter, so we have to divide by the liters. Okay? So we want the liters on the bottom. And this canceled, and this canceled, and that canceled, and that canceled, right? So now we have to get our liters on the bottom here. So to get their liters on the bottom here, what I do is I put a scribble in here, like this. Okay, you see this 31.45 milliliters? I'm actually going to put that on the bottom like this. Because now I have moles per milliliter. I have to convert that back to liters. So 1 times 10 to the third milliliters equals 1 liter. What's nice about this too is that this 10 to the third and this 10 to the third actually cancels out. So I don't need that in my problem. So then I just do 25 times 0.2688 divided by 2 divided by 31.45. And I get an answer of 4 sig figs of 0.1068 moles per liter of strontium hydroxide. That was easily done. Okay, you probably do. Okay, the legend is out. You guys are champions.